Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of function notation. So as per the problem, let f at x equals 3x plus 1 and g at x is equal to 2 minus x. Now we have to find the values of a such that, so for part A, f at a is equal to g at a, and for part B, f at a square equals g at 2a. So let's start with part A. Now we are given that f at x is equal to 3x plus 1 and g at x is equal to 2 minus x. So the first step is to find out what f at a and g at a are. So based on the given function f at x, then f at a will be equal to 3a plus 1. We have to replace x with a, and now we can find what g at a is. So g at a will be equal to 2 minus a. Now we can make them equal to each other and then solve for a. So 3a plus 1 equals 2 minus a. So this is the equation we have to solve. So we can gather and combine the a terms on the left side of this equation and the number terms on the right side of the equation. So we can start by adding a to both sides of the equation. So the a's on the right side will cancel each other out, and on the left side we get 3a plus a, which is equal to 4a. So the coefficient of a is 1, so that's why we do 3 plus 1. Now we can combine the number terms on the right side, so we should subtract 1 from both sides. So the ones on the left side will cancel each other out, and we get 4a equals 1, because 2 minus 1 is equal to 1. And now we can isolate a by dividing both sides by 4, and the 4's on the left side will cancel each other out, and we get a equals 1 over 4. So this should be the final answer for part A. So now we can do part B. So in part B, we are given that f at a square is equal to g at 2a. So first we'll find out what these functions are. So we'll start with f at a square. So for f at a square, we'll replace x with a square in the given f at x function. So we get 3a squared plus 1. And now we can work on the g function. So g at 2a will be equal to 2 minus 2a. Now we can make these functions equal to each other. So we get the equation 3a squared plus 1 equals 2 minus 2a. Now we have to solve this equation to find the value of a. This is a quadratic equation, so we'll move all terms to the left side of the equation. So we'll start by adding 2a to both sides. So that will eliminate the 2a's on the right side of the equation. So we get 3a squared plus 2a plus 1 equals 2. Now we can eliminate the 2 on the right side, so we should subtract 2 from both sides. So the 2's on the right side will cancel each other out, and now we get 3a squared plus 2a minus 1 equals 0. 1 minus 2 is equal to minus 1. So this is the quadratic equation we have to solve to find the value of a. We can factor this expression, this quadratic function. This is a complex trinomial because the coefficient of the a square term is not equal to 1. So we can use the decomposition method here. So for the decomposition method, we have to find two numbers whose sum is equal to 2, which is the coefficient of the a term. And we have to find two numbers that multiply to 3 times minus 1, which is equal to minus 3. So 3 is the coefficient of the a square term and negative 1 is the number term. So we have to find two numbers that satisfy these two requirements. The first pair of numbers that comes to my mind is -1 and 3. So we focus on the product number first. So we find two numbers that multiply to -3. Now -1 and 3 add to 2. So if I do -1 plus 3, I get a sum of 2. And if I multiply -1 and 3, I get -3. So that means these two numbers are the numbers I am looking for. So now we can use these two numbers to break up the middle term two-way. So we can rewrite the equation as 3a squared minus 1a plus 3a minus 1 equals 0. So I broke up the middle term 2a into two terms. Now we can use the grouping method to factor it. So we can pair up the first two terms and pair up the last two terms. And from the first pair, I can factor out an a. And I'm left with 3a minus 1 in the parentheses. And from the second pair, I can factor out plus 1. And I'm left with 3a minus 1 in the parentheses. Because there is no other term we can factor out from the second pair. Now both terms have 3a minus 1 in it, so we can change it to 3a minus 1 times a plus 1 equals 0. So this is the factored form of this equation, and now we get two cases to find the value of a. So the first case is 3a minus 1 is equal to 0. And the second case is a plus 1 equals 0. So from the first case, so we have to isolate a. So first we add 1 to both sides so that the 1s on the left side cancel each other out. So we get 3a equals 1. And now we can isolate a by dividing both sides by 3. So I get a equals 1 over 3. So this is the first solution for this equation. Now we can work on the second case, and for the second case we just have to subtract 1 from both sides. So the ones on the left side cancel each other out and we get a equals -1. So this is the second solution or second value of a for part B. So for part B we got two values of a that satisfy the given equation f at a square equals g at 2a. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.